Sure. All right, let's continue talking about regular expressions. That's what we've been doing lately. At the end last time we had a whole bunch of examples of I describe a language to you and you tell me a regular expression that generates that language. You know, things like, let's say, any x such that x contains a, b, b somewhere as a substring. That would be something like a plus b star, a, b, b, a plus b star, right? Your interpretation when you see this, it means this part could be anything. A plus b means a or b, and enclosing that inside a star means you can take something which is a or b over and over again. Doesn't have to be the same thing. You make a different choice every time. So a plus b star really allows you to put any string right there, followed by a, b, b, followed by another a plus b star. So anything with a, b, b in the middle, and then another anything. And neither of those anythings could be the empty string. All right. Last time we also did something like, how about x contains a, b, b in that order, but not consecutively, or not necessarily consecutive. Not necessarily consecutive. Any thoughts about that? How could we make that happen? Yeah?
A plus B equals star.
Mm-hmm.
And A.
Yeah.
And A plus B star B.
Yeah.
A plus B star B. A plus B star.
I like this. That's it, right? So basically, she says it has to have A, then B, then B. Not necessarily consecutive means there could be some other stuff just jammed in between those letters. And that's exactly what this says. You have the A, the B, and maybe some other stuff stuck all over the place. All right? Sounds great. You could probably simplify that, but I don't care so much about that. All right, how about, I got 3 more, and then we will talk a little bit more abstractly about regular expressions for the rest of the day. How about this one? A to the n where n is even. If you did the homework already, you will have already done something like this. What do you think? A to the n where n is even. Yeah?
A star.
Yeah, I like that. A star. Or you could say a squared star. That's the same thing. Yeah, this is repetitions of AA. Results in a lot of A's, an even amount of them. All right? What if you wanted it to be odd? How would you modify that? Yeah, I think it should be AA star. So that means AA star makes it even, and then you just stick an extra one on. That makes it odd. All right? This is different from, can I say, here's some sort of good sounding but actually bad ideas. That, what does that give you? That's not always going to be an odd. What will that give you?
Multiple of 3.
Yeah, it'll give you where n is a multiple of 3, right? So that's not quite what you need. And you also don't want something like that would just be a to the n where n could be anything. So it's got to be like that if you want it to be odd. All right, how about this? How about all x on, AB star, let's say? X is a string of A's and B's, where the length of x is even. So it could be A's and B's, any amount of them, but the total length is even. Any ideas about that? You can think of it kind of like this one, only, yeah? Yeah. He said A plus B, the whole thing star. I like that. It says I got a something, on another something. So it doesn't have to be an A and an A. It could be an A and a B, or a B and an A, or a B and a B. But you're just taking groups of 2 letters at a time and then repeating that. Yeah, great. This you could also, this is also acceptable. You could just think of, I don't know if this is easier or harder to envision, but this is imagining just all possible ways that you could choose 2 letters at a time, and then saying you can repeat those however you like. All right? This actually, there's kind of a nice little, these are somehow equal by some kind of like FOIL property of this, right? It's as if you were expanding that thing, and you do actually get that thing. So there are some kind of algebra rules that are valid for regular expressions, and that's one of them. There is some kind of factoring and distributing that's possible with regular expressions. All right, great. How about, okay, here's my most complicated one. All x on a's and b's, where the number of a's is even, but there's, also b's in there. The number of a's is even. There's a few ways I can think of doing this, but any ideas? I would think of it maybe like this one. Yeah?
Wait, maybe A or B star, A star, A or B star. Or no, just B.
This is a good idea. Maybe instead of every time you said A or B, how about just B? Is that what you? Yeah. So something like this. This is not quite right, but this is getting there. One thing I don't like about this is it requires the A's to be next to each other. Can you modify that maybe?
I was going to say AA star plus B, and then the whole thing is star.
Okay. I think this also requires the A's next to each other. Yeah. I don't really want the A's next to each other necessarily. Yeah?
Could you add B star in between there?
Yeah, how about put a B star right in the middle right there. That allows the A's to be separated by as many B's as you want. Now, maybe this is good enough. A, B star, A, all star plus B, all star.
Can't start with a B, right?
This can start with a B because you have this outer star here, and the first time through you can choose the B. Yeah, I think that this is correct, although that's not what I was going to say. Yeah, you have a different idea? Yeah.
B star, A, B star, A, B star, all together.
Yeah, this actually was my idea. I mean, I'm not trying to steal, I'm not saying he stole my idea. I mean, this is what I was thinking also. I don't know if this looks more complicated to you or less. I think that these are both correct answers, I think. To me, that one down there is a little more clearly correct, because what I see here is basically, this is, I would say, this is just AA star with B's inserted everywhere they could possibly go. Right? There actually is one problem with this second one that was not a problem before. What were you going to say? Or do you like it?
They can't be only B's.
Yeah, this one right here does not allow for only A's. I mean, only B's. This requires you have at least 2 A's. I would like, when I say the number of A's is even, you want to allow for 0 A's also. How could I change it to make that happen? Yeah, this is kind of a cheap patch, but you can just, as a special case, you can say it might not have any A's, in which case it's a B star, or it's that other thing. Yeah.
So like when we did above, where we did place the n with n is even, would
Yes.
we do the same thing? Would we say AA star is how that?
Yeah, right. That's the idea. This here is basically the same as AA star, only you've inserted B's in everywhere, every which way.
Right. So like the one we did above, though, we would have to add the B star. I don't think
No, because this just says A to the
Oh,
n.
that's right.
So there were no b's involved in that one. Yeah.
So why do the, in the last example in that group there, why do the B's have stars on the inside? Like, do you need the stars on the inside or can you just have the outside?
Yeah, you need those stars, because if it said B, A, B, A, B, the whole thing star,
Yeah.
this allows only that specific thing there, B, A, B, A, B. It doesn't allow, for instance, A, A. Like if you really wanted an A next to an A, you couldn't do that using this.
So you could have AA in the first one because
Yeah.
the star is 0, right?
Yeah, that's right. Yep. And this also would not allow for several B's next to each other, because if you wanted to do something like A, B, B, A, you can't do that here. ABBA. Right? Okay, great. So these can be a little tricky sometimes. I mean, if you look at the homework, a truly ridiculous homework problem which has like A, B, C parts all the way down to U or something. It's silly. All right. So my big question, all of these examples, big question that I want us to consider for the remainder of today and maybe some next time also. And I think I've already posed this question before. What languages can be represented by regular expressions? All right. Apparently all the ones that we just did, they can, because we just did them. But are there some languages you can imagine that you cannot do a regular expression for? The answer actually is yes. There are some languages which regular expressions cannot represent. So I want to talk about exactly what sorts of languages can you do with a regular expression. So specific question would be something like, can I do any regular language with a regular expression? Or maybe the other way around, you could also ask, if I have something from a regular expression, is that automatically a regular language? And it's actually that second thing that we're going to talk about today. So we're not going to fully answer that question today, but one thing that we will talk about is there is a method, and it's not hard to do, to convert a regular expression to an NFA. There is a method that always works to convert any regular expression into an NFA. This means, in terms of the theoretically speaking, what does this mean about the kinds of languages which can be expressed by regular expressions? Yeah? They are the same type, not necessarily the same type, but it means if you have a regular expression, you can do it as an NFA, right? Now, it may not be that you could take any NFA and turn it back into a regular expression, but it is true that any regular expression, I think it means that any language expressed by a regular expression is regular, right? Because you can do it also on an NFA, and the things you can do on NFA, those are called the regular languages. So, if you believe me, and you're going to believe, it's not hard to do, this method to convert a regular expression to NFA, just the fact that such a method exists, it means that anything you can do on regular expression can be done on an NFA. Which means any language expressed by a regular expression is a regular language. So in the sense of our, languages we've talked about so far, we have DFA and NFA, which have the same expressive power. And this actually means that regular expressions, if anything, they are less, they cannot express more than an NFA, because it is possible to convert any regular expression into an NFA. So they don't do things. They don't do other things. They may do less, but they don't do more. All right? Any language expressed by a regular expression is a regular language. That's actually why they're called why they use the word regular. I'm actually not sure what came first, the word regular as in regular expression or the word regular as in regular language, but they are, the same word is being used both times for a reason. All right, let's talk about how we do this conversion. So the conversion is not so hard, and it's actually closely related to things that we have already discussed. So to convert, I'll start a new page here. How do we convert regular expression to NFA? What I'm going to do is we're going to sort of build the NFA in little blocks. You start with perhaps a complicated regular expression, and you want to look at the various pieces of the regular expression and turn it into parts of the NFA diagram. And I'm going to say build it in blocks based on atoms and operations. I don't know if you remember, the first day we talked about regular expressions, I said the structure of a regular expression is it has atomic parts, which are basically just the individual letters, and perhaps the empty string. Those are called the atomic regular expressions. And then those things are combined together using the operation. So I'm going to describe how you convert each of the atoms, the atomic expressions, to NFA, and then how do you convert the operations to NFA? Check it out. This is not so hard. So first of all, the atomic regular expressions. Those would just be individual letters, or the empty string, or the empty set, which we almost never use for regular expressions in the real world. But atomic regular expression, how about the a letter, say the letter A. I want to say, if it's just the A, how do I convert that into an NFA? This will be an NFA which accepts only the letter A and rejects everything else. Anybody say how to draw that? I see people doing this. Yes. There's a starting state, and then? Yes, just like that. All right. So this is a NFA which accepts the letter A. Not too fancy, right? I'm going to do these, by the way, and you'll see why in a moment. Let's use only one accepting state every time. You'll see why I want to do it that way, and it's not a big deal anyway. How about the empty string? Can I make a NFA which accepts only the empty string? Yes? How do you do it? Yeah, just that, right? This is an NFA which accepts the empty string, and it accepts no other strings, because if you try to do any other string, you get stuck. And so it gets rejected. All right, that's a NFA which accepts the empty string. And how about the empty set? Now, the empty set in a regular expression matches nothing. So I want to write an NFA here which matches nothing. Any ideas? Yeah?
Just be like the circle by itself.
Yes, with no accepting state. Now, this is the appropriate answer. Although, for technical reasons, which you'll see why in a moment, I said let's use one accepting state every time. I want to draw this so that it actually has an accepting state. And the way to do this is like this. No arrow. Nobody ever asked me this. In an NFA, are you allowed to have something like that? With just like a state that's not connected to anything? The answer is, yeah, you are. In a DFA, this is not allowed because every state needs outgoing arrows labeled with every letter. But NFA can have any number of states and any number of arrows. You can have states which are just totally disconnected from everything else if you want. Yeah.
For the empty string NFA, could you also write a state with an epsilon transition to the
Yeah.
state?
So this is also acceptable, although the one on the left is a little simpler, so I'm going to do it the way on the left, but I will put this one in brackets, or that's also correct. Yeah. Or there are many other stupid ways you could do this empty set thing, like I could just sort of do that. This is the same, right? Those extra states just have no effect on anything, but I'm not going to do that. That's silly, right? Come on. I'm just joshing you. Okay? Those are the atomic regular expressions. Let's talk about the operations now. You know, an interesting regular expression is not just one of those. It consists of those combined together using the operations. And let's talk about the operations. And here you're going to see stuff that looks very familiar. What about the plus? What this means is if I have something like I have, it's 2 words. If I have NFA already for 2 different regular expressions, R1 and R2, then the NFA for R1 plus R2 is... Does this sound familiar to anybody? Remember, we did something very much like this. Yeah, the plus means like or, which as sets, this is the same as the union. And we have talked about a way to combine NFAs together with a union. And remember that? Give me a hand gesture to suggest how we do that. Yes, something like this. You want the branching path thing. So it looks like this. I start here, I do 2 epsilons, and then those epsilons send you into the starting state of some NFA over here, whatever, right, for R1. So I'll just label that with the R1. And then down here, it goes into the NFA for R2, right? And because I said I want always to have a single accepting state when I do these constructions, I'm going to take these, whatever accepting states there were in there, I'm not going to make them accepting, but I will tie the end states by epsilons into a single accepting state here. So when we did this before, I did not sort of tie it up at the end. The purpose of tying them together at the end is that I intend to sometimes plug this in front of some other thing, right? I want to be able, in a regular expression, to combine this with a plus, but maybe I want to combine that with another plus or with a star or something like that. It's most tidy to do that sort of over and over again if you always tie it up into a single starting state and a single accepting state. This makes things easy to plug one after another, these blocks. Whereas if you have 2 accepting states, then it's not a big deal, but it's a pain to deal with. All right, that's how we handle the plus. Anybody remember there was one other kind of operation of this type that we discussed a couple weeks ago? Yeah? Yeah, it was the concatenation. And that also is one of the basic operations of a regular expression. So let's do that. So there's also the concatenation. So if I have already NFAs for R1 and R2, the concatenation, the NFA for R1, R2, that is the concatenation of the regular expressions, is your starting state. It goes epsilon into the machine for R1. This goes epsilon into the machine for R2. And then, for the same reason as before, I'm going to put epsilons into a single accepting state. So if you had several accepting states at the end of R2, you just tie them all together by epsilons into a single accepting state. That is for convenience in plugging this into another operation once you're done. All right? Is this all that, I'm trying to talk about all the different operations. Is that it? We got the plus, the concatenation. In terms of regular expressions, I think there's one other thing to discuss. The star, yeah, that's the other operation that is important in regular expressions. So let's talk about the star. The Kleene star. Remember, that's the name of the star. All right, well, if I have a regular expression for, in this time it's just a r, right? It's not like 2 This is not a binary operation where you combine two things. It's just you just have one thing and you put a star next to it. If I have a regular expression for R, let's say, then I meant NFA. This is what I'm saying every time. If I have an NFA for R, then the NFA for R star is, this one's going to look a little cuter. Anybody have an idea? I am going to begin like I did up there. I'll have a starting state which epsilons into the R. I want an NFA which allows you to do R over and over again. That's the idea of the star. Yeah.
We have a loop to your side.
Yeah, have a loop going back to the start, really. So what I'm going to do is, just for convenience, tie this into, in fact, we can make that an accepting state. And then, from that accepting state, allow it to go back and make this an epsilon also. So you get to the end, and if you want to, you can go back to the beginning and do it again. And continue to do it again as many times as you like. This is the NFA for R star. Yeah?
Could you have done an arrow back from R itself?
You mean like this?
Yeah.
Yeah, it's kind of ambiguous what that means. Because R, remember, R represents, there's like an entire NFA inside that box. So I would rather not. I mean, I kind of know what you mean if you say that, but it's we don't write it that way. There's actually one very slight problem with this. There's a modification that we need to make here. R star, remember, allows for any number 0 or more repetitions of the R. And if you see something about this diagram, it's not quite the same as that. Yeah?
You have to have like at least one.
Yeah, according to the diagram, to get to the accepting state, you got to go through the R at least once. And we don't want that, actually. We want to allow possibly 0 repetitions. Anybody see how we can do that? Yeah.
Just the arrow goes straight to the.
Yeah. Like that. All right? So this allows you to skip the R entirely if you want to. So the purpose of that last arrow that I drew at the bottom there is just so that if you want to, you don't have to do the R at all. All right? But anyway, this is the NFA for R star. The question?
So, like just doing the spontaneous transitions through the middle, that means you're still like considering R's in this case. So you want to skip it entirely.
Yeah, like this one going through the middle? Yeah, so what this diagram is supposed to represent is, in here you have a full NFA representing R. And so you transition into it without using up any letters, but then in order to make it through this block, you have to do whatever the letters required by R is. Yeah. All right, so the procedure for doing this, convert regular expression to NFA, you basically have to memorize these 3 sort of schematics here. This one, and this one. They're not so hard to memorize. I'm not big on making people memorize a whole lot of stuff, but I find them easy to remember. They're nice looking pictures, you know. And then when I give you a regular expression, you kind of try to break it down into its component pieces and then piece those 3 separate schematics together in whatever way you need to. Let's try some examples. I got one, and then I want you guys to try one. How about convert, let's try, actually, let's do a very simple one first. I want to kind of build up to this, sorry. So how about a NFA for the language of A plus B? All right, this is a very simple one. The language of A plus B, that would be an NFA which accepts only A or only B. Now, I'm not going to think of it in those terms. I'm going to try and just do this procedure as we've described it. So what I'm going to do first is, for A, I use this NFA. That was the atomic, the NFA that you get using the atomic just A. And then for B, it looks like same thing, but with a B, all right? And so for a plus b, I add those together, and the plus is the one with the two branching paths. And so a plus b is, I have a starting state, I go epsilons, and then up top I do the a one, up the bottom I do the b one, and then those, rather than making them accepting states right there, I'm going to tie them with epsilons both into a single accepting state. So right up here, you see I used the first machine, and then down here I used the second one, right? That would be a plus b. All right. This is a very simple one. I'm going to try and sort of ratchet up the complexity a little bit. What about, let's try a plus b followed by a. This is a concatenation where the first thing is a plus b, and then the second thing is a. And so I take the machine for a plus b. It's a concatenation, right? That's the thing. Concatenation is when you do one of them, send it directly into the second one. So I'm going to do the first one. Well, I have a starting state with the epsilon transition, and then in here I'm going to copy the a plus b machine. So that's this. This is the one we just did. All right, that's the a plus b machine. And then remember the strategy for concatenation is you do the two things sort of right next to each other in series. So I'm going to put epsilon here into the machine just for a, right? Because this is a concatenation of a plus b and a. So the machine just for a is this one. And that's it. So this over here is a. That's a concatenation of a plus b followed by a. All right. How about this? I will do one sort of more interesting, bigger one, and then I got one for you to try. Let's try a b star, a plus b. This one's a little more interesting. What we have here is a concatenation of three things. The first is a, which is easy enough. The second is ab star, and the last one is a plus b. So can I just say, this, once you know what you're doing, you can sort of jump to the answer maybe, but I'm just going to write down the various pieces. There's the a, which is this, of course. There's ab star. Maybe I'll just start with ab. ab looks like a concatenation of a followed by b, so that would be a followed by b, right? This is ab. Now this is not the simplest way, but going strictly by our procedure, what you want to see here is the a with the epsilon transition into the b, all right? Now, in reality, actually, you could sort of simplify this by leaving that epsilon out and just making it go, I will say, you could just go directly like this, a, b, right? Those are the same. So if often it's possible to kind of simplify by omitting some epsilons. You can if you want to. You don't have to. Yeah.
And you can remove that epsilon because you know that a is always going to be followed by b, right?
Yeah. I mean, this means you do a, then you just go over here without doing anything, and then you do b. That's the same as just doing a followed by b. So those are equivalent. All right. Now, what I'm trying to build up to is actually has an AB star in it. So let's try to do AB star. What would that be? Well, it would be this or this one, but wrapped in those like cyclical epsilons. That's how you do the star. So I'll use the more complicated looking one, but it is. All right, that is AB, and then to star it, you put a epsilon going back from the end to the beginning, and you also put an epsilon going from the beginning to the end. So that is AB star. And then the last piece of this big regular expression that I'm trying to do is a plus b. So I'll write that. That also is pretty simple. It's one of these, right? A like that, b like that, whoa, b like that, like that, all right?
I have a question.
Yes,
I'm not sure why, maybe I forgot the reason, but why do we need the epsilon? Why can't we just do on the starting state A up and the starting state B down?
you can. Yeah, on this one that I just drew here.
Yeah.
Yeah, this actually, if you simplify it, this is the same as,
The AB squared is wrong. It's supposed to be epsilon squared, the sign state. You write A to epsilon.
sorry, here?
Yeah.
Oh, that's just my handwriting. This is the epsilon. Yeah, sorry about that. Yeah, there are simpler ways that you could do this. Like this one, you could do like this. I think this is what you are saying, right? Yeah. Yeah, you could do that. It's just in general, the general strategy for indicating a plus is to do two branching epsilons at the beginning. But it's equivalent, I mean, in this example, you can do it like that. And in fact, this one also you can simplify by just, if you wanted to, it's actually just this, right? That's the same, that's even better. But when you're doing these kinds of examples, I mean, if you want to, you can try and simplify them in your head as you go, or not. It's a little easier to not try to simplify them, but you can if you want to. All right. Anyway, what my final answer will be a NFA for this big thing, right? That's what I was trying to do. So it consists of a concatenation of the A machine, which is the one on top, then the AB star, then the A plus B. So what it looks like is first the A, that's this, followed by the AB star, that's this. A, what was it? Sorry, it started with the epsilon. Again, you can simplify it if you want to. Here's the epsilons that make it a star. All right. So first I have A, followed by that big thing there is AB star. Maybe I'll put a little, that's A. This is AB star. And then followed by A plus B, which is this. There you go. This is A plus B. So that whole thing is A, B star, A plus B. All right. All right, I got one for you to try. We got 10 minutes left. I think that's enough time for you to try one. Make me a NFA for A squared plus B star BA plus epsilon. See what you think. I'll give you a moment. I'll walk around and see how you're doing. Yeah, sure. Put that right at the bottom.
that makes it useful now. So, you know how we set it up over here, we started with like this.
Yes.
How come we don't have to start with like a epsilon over here? Like why don't we can just jump right into this?
Yeah. That one.
Oh, okay, that makes sense.
Yeah, like here, I didn't just have here. Right now, it's really bad. Yeah.
Okay. Alright.
And then 4BA, which is the okay. Connect each thing with, since we're connecting this chat, you need to connect it with an epsilon. So this goes epsilon, 4BA.
Well, why do you need that? Why do you need
This is.
Maybe you can, epsilon, maybe you can, that won't be one of the six.
Yeah. There's an RA.
And then you get this thing here. And then, but then, you have a union that connects this whole thing to the empty.
Does that mean you can deny that to the
It's
space?
so, I don't know.
I'm gonna do this.
No.
I'm gonna do this. Look at that, look at that.
Because the stars on for both.
There we go. There we go.
With the, on these two.
There we go. I win.
This is the square star.
Yeah.
And that's the
It's like hurts a little.
That's not how.
Like you have to do the x square plus b,
And then it's draw the whole thing. Okay.
which is.
Okay. You say Legos are fun.
It's okay.
Yeah.
We good? Good work.
The whole thing. Or just like that.
Yes. Yeah, so we use like the usual order of operations. So plus the grouping is like this. You consider all that together. Yeah, groups like that. I'm gonna start drawing mine because we got to go in a few minutes.
Carson accent, yeah. That's why I did that. I want to see my grade. Don't tell me the grades are close. Don't tell me the grades are close. I don't want to see it.
All right, it's time to go soon, so let's chat about this. So I started by, you can start all the way from the atoms. I found it not so hard to jump to this as a starting point. A squared plus b, the whole thing star. So because it's on the inside of the parentheses, it's a plus. So you want this kind of two branching paths where one of them is a squared and the other is a b. So what you see in here is a squared plus b, and then to star that, you put epsilons going back and forth on the around the outer edges of that.
Can I put an epsilon between the A's?
Yes, yeah, if you followed specifically the constructions that I said before, there would be another epsilon going in between the a's, and that's fine if you want to. I left that one out, but I think I put all the other ones in. And you could even omit several of the ones that I've used here. All right, and then So that's a squared plus b star. That's the most complicated part. What we need to see also is that thing concatenated with a BA, so that we can just do a B and then an A, right? Again, you might have extra epsilons in there if you want to follow precisely the construction. And then it's this plus epsilon. So it's all of that or epsilon. So actually, to construct the plus in the way that we usually do, this is two things which are combined with the plus. So what I've drawn so far is just the upper branch of a plus. And the lower branch is just an epsilon. So this I will tie into the final state like that. All right? Yes?
Could you just like connect the starting with the final?
Yeah, so this kind of epsilon followed by another epsilon is really the same if you want, if you prefer, as just one big arrow with the epsilon there. Yep. But I was trying to emphasize the structure of this plus. The plus right here makes two separate paths, where the top one is that complicated thing and the bottom one is just epsilon. All right?
Is the last state accepted?
Yes, yeah, thank you.
Oh.
I get wrapped up. I forgot my accepting state and I forgot my starting state is obviously over there. All right? So, the moral of the story, any regular expression can be converted into NFA. It might be pretty big, but it is possible. Next time we'll talk about going the other way. Is it even possible? Take an NFA and turn it into a regular expression.